Hello, today we're going to talk about decorators in Python. So a decorator in Python is any callable Python object that is used to modify a function or a class. We usually we define decorators usually as functions, and the whole procedure is that we define a function that we call decorator function, and the argument for this function is another function. So inside of this function, we had the nested function, usually called function wrapper, that takes some input from the function func. The work of the function wrapper is to do some kind of transformation of the arguments and call the original function with the transformed input. So the decorator will actually return the function wrapper, so it will return a closure. So here we define, as an example, a function foo that actually prints a specific string. Here we call foo and we can see the result, and then we create a decorator. So the decorator is going to have foo as an argument, which is a function, and it will return a closure that is going to be calling this function foo. So by using the closure, as we've seen in the videos with the closure, and specifying 72 and specifying 42 as argument, then we can see that foo 42 will run inside of the function wrapper and we get the specific result. So another way to use decorators, which is the more Pythonic way and a simplification of the process, is actually using the email sign and the name of the decorator. So what happens here is that we get the decorator is defined and then it is called automatically by the system. And this is exactly the same as here. So another way or another example is when we have Another example is when you have a sac function and you want to add one value to it. We also have a decorator here that actually calls this function and prints the resulting value. So before calling sac, we get the message before calling sac, then we get the value of 11, and then after calling sac. And this is another example of a decorator. We can also define multiple decorator functions that are going to be used only on one function. So for example, we create decorator 1, 2, and 3. And this will do a different transformation to the input. And actually they will return a quite different output. So when we use the .@deco, what we do is actually run a part of the closure, which is the prints, and you can see that the prints are run from the first function to the last, but then when we call the closure foobar, we can see that there's quite a big difference. So for example, the difference here would be that the decorator 3 is the closure that runs first. So it's the closure that is passed to memory last and it's run first. So it's the inverse transformation. So pay close attention to that. And the result of foobar 42 would be 48. So why would it be 48? We have to think a little bit about it. Yeah, it will be 48 because the decorator is applied. So it goes to 45. And from 42 it goes to 45, 47, 48, and the resulting value will be 48. Even though the return value here says 42, because the foobar is actually called here, and then the resulting value is going to be appended through the decorators. And there are quite a lot of other examples here that you can test, and you can actually use decorators like argument test natural number that check the input as I've told you before. So here we check the type of the argument x and whether x is more than 0. So this way we check if this natural number, else we throw a value error. And we use this function for is prime, and you can see how this code would run. So yeah, that's all for the decorators in this way. We can also define a decorator function that does some kind of call, or let's say some kind of counter. This is really, really useful because counters are usually so this is very useful because this way you can define the counter value. So we have a helper, and we define helper.calls to be plus equals to 1, and we define this function, this variable here equals to 0. So each time we call suck, the helper.calls will increase by 1. So the first time we are going to be creating the helper.calls, and we will equal it to 0. And then for each successive call, we're going to be adding the value of 1. So we will have a counter, and we see the result of the counter, the suck.calls, being equal to 10. So again, using the email symbol, we can actually change the code from using the decorator and passing the function as an argument by using this notation. So finally, we can also define a callable class. So here we define the callable class called star. It has some kind of internal variable, and then it has a call method. And there's also an input wrapper here. And this is again a case of a decorator inside of a class, which is absolutely crazy. So here you can see how you can call the class, initialize it with a specific value, and then it's automatically called because this is automatically triggered. And you can see the result here. So it prints 5 times the asterisks, then calls the function add for the argument input, and you can also have arguments on your decorator function, on the nested function, by using the asterisk args, a double asterisk k args. So you can see that the addition is actually happening, and then again we have some other asterisks.